Let's hit the dot. In the following lesson, we will determine how this man will use his sphere to hit the apple on the target and get it down successfully while using dot product. Now let's presume this man is standing 5 units in the x direction from the tree and 0 units in the y direction, and presume that his sphere must be pointed 12 units in the x direction and 15 units in the y direction. We'll call this vector A, and we'll call this vector B. Now the big question is, at what angle must this man point his sphere in order to successfully get this apple down to the ground? And in order to do this, we must use dot product that incorporates an angle between two lines. The formula for this is vector A times vector B equals the magnitude of vector A multiplied by the magnitude of vector B multiplied by cos theta. Now let's take this step by step. First, we will find the dot product of vector A multiplied by vector B, which is equal to AX times BX plus AY multiplied by BY. Now let's plug in our values. We know that AX is 12, BX is 5, and we're going to add that to AY, which is 0, and BY, which is 15. In total, our dot product between vector A and B is equal to 60. Next, we'll find the magnitude of vector A, which is equal to the square root of 12 squared plus 15 squared. In total, our magnitude of vector A is equal to root 369. Now, our magnitude of B is equal to the square root of 5 squared plus 0 squared, which in total gives us a magnitude of B of 5. Now that we have all our values, we can put them all together. Here's a recap of our formula. Vector A times vector B equals the magnitude of A multiplied by the magnitude of B multiplied by cos theta. Our value for A dot B is 60. Our magnitude of A was root 369, and our magnitude of B was 5, all multiplied by cos theta. Now we'll need to get cos on its own, cos theta specifically. So we'll divide out root 369 multiplied by 5, which gives us 60 divided by root 316. Yes. Oh my goodness, you guys really don't care, do ya? Multiplied by 5 equals cos theta. Now, we have to leave theta on its own. So, we'll take the inverse of cos, which will give us theta equals 60, the cos inverse of 60 over root 369 multiplied by 5. In the end, theta equals 51.34 degrees, which we can say theta approximately equals 51 degrees. Now to conclude, we know the magnitude of the man to the tree is 5, and the magnitude of his sphere to the apple has to be root 369. We also figure out that the angle at which his sphere must be projected is 51 degrees. Now, our man has successfully brought the apple down. Congratulations!